In the figure below, P, Q, R, S, and T lie on the circumference of the circle center O. Line UPV is a tangent to the circle at P. Chord ST of the circle is produced to intersect with the tangent at U. Angles UPT, RST, and ORQ are 28, 100, and 50 degrees respectively. So the diagram is there. You can see all the angles indicated. Now the first part of the question, determine the sizes of the following angles. The first one is RTP. So we identify that angle first, RTP. The diagram, RTP is this angle. So that is the angle that we need to get. Now while solving this question, you need to be familiar with most of the angle properties of a circle. Otherwise, it will become very difficult if you've not gone through all the properties relating to circles, chords, and tangents. So let us go through. I will be giving the reasons for the answers I will be getting for all these angles. So like for this one, when I look at this diagram and all the angles that are given, there are angles that I can be able to feel. The first one, I look at this tangent VPU, and that tangent, and then you have this angle here is 28. So when you look at this angle, which is 28 here, and this is a tangent, there's another angle. I'll be able to get this angle. So this angle that is here, and I'll give the reason for that. So angle TPU is equals to, that will be the same as angle TQP, angle TQP, and that one, both of them are 28 degrees. Reason, these are angles in the alternate segment. Angle TPU, which is 28 degrees, is equals to angle TQP. So this angle is 28 degrees as well. After getting that, I'd like you to look at this quadrilateral. So quadrilateral RSQT, RSQT. And I'd like you to look at this angle that is here, this angle S and angle Q. Those are two opposite angles in a cyclic quadrilateral. And the property relating to that is that the sum of two opposite angles in a cyclic quadrilateral should be 180. And therefore, let me first write this. So angle RST is equals, not is equals, but plus angle RQT plus angle RQT, that one should give 180. And therefore, if this S is 100 degrees, then this one should be 180 minus 100, and this one will be 80 degrees. Now, once we've done that, there's something else that I can do. Now, look at the center RO. O is the center of the circle. And let me see whether so far I'll be able to get angle RTP. Yes, I can be able to get that by considering these quadrilateral. So consider this quadrilateral RTQP. RTQP. Look at that quadrilateral. And then you look at this angle RQP, angle RQP plus angle RTP. Angle RTP, that is the required angle you're supposed to get. That one you should get 180. Again, these are opposite angles in a cyclic quadrilateral. The quadrilateral is RTPQ or RTQP. RTQP. So that is the quadrilateral. And when you get the sum of the opposite angles in that cyclic quadrilateral, you should get 180. And therefore, the whole of this angle Q is 80 plus 28. That will be 108. So we're going to get 180 degrees, subtract 108 degrees, and this one should give 72. So the whole of this angle is therefore 72 degrees. So we have already obtained that. So that angle is 72. In case you're required to give the reason, you could have given that reason. These are the sum of two opposite angles in a cyclic quadrilateral is 180. The other question is question part 2, QTP. QTP, angle QTP. So which is that angle? Angle QTP. So angle QTP is a QTP is this angle that is here. Is this angle that is here. So how do you get that angle? To get that angle, I'll try to join. If I join from the center, so from the center, let me make this one smaller. So from the center here, center O, if I join that using a straight line, so I draw a straight line from center O to T, there is an angle here I can get, and the angle is look at this angle. If we have the angle subtended at the center here, this angle subtended at the center here, to look at it, the angle subtended at the center here is twice the angle subtended at the circumference by this chord RT. The angle subtended at the center by this chord RT. This chord RT subtends 100 degrees at the center. So this angle at the center here should be twice the angle subtended at the circumference. So if the angle subtended at the circumference is 100, then this angle should be twice that, should be 200 degrees. So if that angle is 200 degrees, then the other one that is here, this angle should be, because of the sum of angles at a point, this angle should be 160 to make 360. So 200 plus 160, 360. Again, this is isosceles triangle. So if this angle is 160, then this angle should be 10 degrees. And then this one is 10 degrees because this one is forming an isosceles triangle. So this angle here, 10 degrees, then this one is 10, then this one is 160. Now, I think with those angles that are filled, I'll be able to get this angle now. QTP is this angle that is here. I'll be able to get this angle. Let me first rub this one so that I can rub that on so that I can be able to indicate this angle clearly. The angle that is required is this. This is the angle. So again, I would like you to look at this quadrilateral. So RQPT. That is another cyclic quadrilateral. And the opposite angles, two opposite angles, are supposed to add up to 180. So this angle, I'll indicate it here. So angle QPT plus the other angle is QRT. That one should give 180. So those two angles, and you have this angle at that is a QRT. QRT is a 50 plus 10, that would be 60 degrees, and that one tells us that this angle, we'll be able to get this angle. This angle should be, that is angle QPT, this one should be 120 degrees. So this angle here should be 120 degrees. Now having that, it is easier now to get angle QTP. QTP is here. We are going to consider this triangle QPT. Triangle QPT. We have 120. So we have 120. And then we have 28 degrees. That gives 148 degrees. So the sum of angles, interior angles in a triangle, should give 180. So we get the remaining one. You just take 180, subtract 148. And that one should give 32 degrees. So this angle here is 32 degrees. So we have given the two angles. Now you can see that we are using all the properties of angles that we know to get the angle. So those are the two angles. RTP 72 and then QTP 32 degrees. We go to the other part. Part B. Given that PQ is equals to 6 centimeters, calculate correct to one decimal place the radius of the circle. PQ is given here. PQ is 6 centimeters. So it's supposed to give the radius of the circle. Now, because these I'm going to extract that triangle QPT. I will extract that triangle QPT. So triangle QPT. Let me extract these. Triangle QPT. So PQ is 6 centimeters. And then we have the angles 120, 28, 32. 120, this is 120, this is 28 degrees, and this one is 32 degrees. So you're supposed to find the radius of the circle. Now, how do we find the radius of the circle? There is a concept that we need to understand before we solve that question. You can see that this triangle is circumscribed. There's a circle that is circumscribed onto that triangle. There's a circle that is touching the 3 vertices of that triangle. And if you recall about the sine rule, we can use the sine rule to get the radius of the circle. And this is the sine rule. Just to remind you, A divided by sine A is equals to B divided by the sine B is equals to C divided by sine of C is equivalent to 2 radius. This is the concept that we need to use in order to get the radius of the circle. Now, we don't need to have all the angles and all the sides. We simply need to get a side and an angle. And when I look at what we have here, I can use that side QP, and then the angle that is the opposite, that is 32. So from these, I can get 6 divided by the sine of 32. That one should be equal to 2 radians. That is what you're going to use. Simple as that. And this one should give, so 6 divided using a calculator, 6 divided by sine 32, 6 divided by sine of 32, that gives 11.32. That is correct to for significant figures is equals to 2 radians. So divide both sides by 2 to remain with R. So if you divide this one by 2, you get this one is 5.66. So correct one decimal place, you get 5.7 centimeters, and that is the radius of the circle. That is how you're supposed to solve.